Welcome to SST Joy. Students, as you know that nowadays we are studying our geography 4th chapter, that is the distribution of continents and the oceans. So in our last video we have studied about the formation of continents, in which we have studied the Wagner's theory. In that study, we have studied about the continental drifts, and we have also studied how a supercontinent, which is Pangea, it is divided into two major parts. These were the Laurasia, the northern part, and the Gondwana, that is southern part. So in this series, our today's video, we will study few more topics about the distribution of oceans and the continents. So our today's first topic is ocean floor configuration. The ocean floor may be subdivided into three major divisions based on the depth as well as the forms of relief. That means the ocean floor, which is too deep in the sea, that is divided into three major parts, and these major parts are categorized by their depths and the reliefs. So these divisions are the continental margins, second abyssal plains, and the third is mid-oceanic ridge. Again I am repeating, the first is continental margins, the second is abyssal plains, and the third is mid-oceanic ridge. So now one by one we will see these three major divisions of the oceanic floor.
The creation of new oceanic crust at the mid-oceanic ridge moves the continents across the Earth's surface and creates zones. So, the first zone is continental margins. The continental margin is the shallow water area found in proximity to continents. The continental margin consists of three different features: the continental rise, the continental slope, and the continental shelf, as you can see in this given picture. Continental margins constitute about 28% of the oceanic area. Second is an abyssal plain. An abyssal plain is an underwater plain on the deep ocean floor, as is visualized in your screen. Usually found at depths between 3000 meters, or we can say 9800 feet, and 6000 meters, laying generally between the foot of a continental rise and a mid-ocean ridge. Abyssal plains cover more than 50% of the Earth's surface. The abyssal plains are the areas where the continental sediments that move beyond the margins get deposited. The third part of seafloor is mid-ocean ridge. A mid-ocean ridge or mid-oceanic ridge is an underwater mountain range, typically having a valley known as a rift running along its axis, formed by plate tectonics. This type of oceanic ridge is characteristic of what is known as an oceanic spreading center. The uplifted seafloor results from convection centers that rise in the mantle as magma at a linear weakness in the oceanic crust and emerge as lava, creating new crust upon cooling. A mid-ocean ridge demarcates the boundary between two tectonic plates and is therefore called a divergent plate boundary. The mid-oceanic ridge is also responsible for the earthquakes and the volcanoes. So, how the earthquakes and the volcanoes are distributed, let's see in our next topic, distribution of earthquakes and volcanoes. Now, let's see our next topic, that is distribution of earthquakes and volcanoes. Students, already you have studied about the earthquakes and the volcanoes in your third chapter, which is inside our earth. Now we will see the distribution of earthquakes and the volcanoes, how they are responsible for the distribution of oceans and the continents. Let's see. The plate tectonics cause earthquakes and volcanoes. The point where two plates meet it is called a plate boundary. Means, if you can see, if these are two plates where the beds of the plates are meeting, that point is known as the plate boundary. This is the plate boundary. Earthquake and volcanoes are most likely to occur either on, means that place, or near the plate boundary. Either in that place or in that place the earthquake may occur. In the same case, that is also applied for the volcanoes. Where is the plate boundary is meeting, that is the main point of the volcanoes and the earthquakes. As you know that this meeting point is joined with a vent, which is the vent is joined inside the earth where the lava is there. Okay, so what is that? The earthquake and the volcanoes. The main part of the volcanoes and the earthquake is that point, that the meeting point. It is because it is a pass for this vent through which the lava or magma can be out, and we can say it is also a cause of earthquakes. So students, here we can see the plate tectonic cause earthquake and volcanoes. The point where two plates meet is called a plate boundary. Earthquakes and volcanoes are most likely to occur either or near plate boundaries. As all volcanoes and earthquakes are parallel to the coastline, this line also considered with mid-Atlantic ridge. The distribution of volcanoes and earthquakes around the Pacific Ocean. It is known as Ring of Fire Mid-Oceanic Ridge. If we will talk about the earthquakes, earthquakes usually occur at destructive and conservative plate margins. Minor earthquakes can occur at constructive plate margins. Intraplate earthquakes occur away from plate margins. The reasons for this are not fully understood, but it is thought that they are caused by convection currents in the Earth's mantle. On the other hand, if we will talk about the volcanoes, volcanoes usually occur at constructive plate margins but can also occur at destructive plate margins. Earthquakes can be triggered by human activities such as underground mining and others. The ring of volcanoes and earthquakes around the Pacific plate, as I told you, and it is showing on that screen, that is known as ring of fire. So, question is there that is there any relation between the plate tectonics and the interior structure of earth and the seafloor? So, to know the answer of that question, let's see our next topic, which is concept of sea floor spreading. Now our next topic, which is concept of sea floor spreading. So what is sea floor spreading? Actually, the theory of seafloor spreading, it was proposed by Hess. It was proposed by Hess in 1961. What he has proposed? What was in that theory? That seafloor spreading is a process that occurs at mid-ocean ridge, where new oceanic crust is formed through volcanic activity and then gradually moves away from the ridge. If we will see the theory in that way, earlier the old one theory, the oceanic plates, it is the early theory according to Hess. Here it is the mantle and this is the seafloor. In the advanced one, it has spread more than this. It was like that. It is advanced one. Advanced one, the mantle, now it is spread, the plates spread. Then after that, the new one, if we will see the new one, now it is like that. This is now in this form. The newest one form of that, the seafloor, looks like this. It is mantle and this is the crust. So what is the need of that theory? Actually, this theory informs us about the plate tectonic theory, which we will study in our next video. So what is the concept? Again, see, seafloor spreading is a process. It is a process that occurs at mid-oceanic ridge. It is the mid-oceanic ridge. Here this process occurs. See, first of all, it was in that shape, then it spreads and it came into the advanced stage, and then after that it changed into a new form in which the mantle and the crust, they are having a thin layer, and it is formed through volcanic activity. As the volcano bursts and the magma come out, it is forming a thin layer of crust and it is making a new concept, that is the concept of seafloor spreading. See, gradually it moves away from the ridge. It is the ridge and it is moving away from that ridge. Seafloor spreading helps explain continental drift in the theory of plate tectonic. The theory which was proposed by the Wagner of the continental drift theory, for support that Wagner theory has proposed a new theory which is seafloor spreading, and in that theory he is telling us about the plate tectonics theory, which is more explaining the distribution of the oceans and the continents. How? Let's see now.
As already I told you, the concept of seafloor spreading theory was proposed by Hess in 1961. He believed that new lava pushes out the plates from the mid-oceanic ridge. As the post-drift studies after the Wagner's theory provided considerable information that was not available at the time Wagner put forth his concept of continental drift, particularly the mapping of the ocean floor and the paleomagnetic studies of rock from oceanic regions revealed the following facts. The paleomagnetic studies of the ocean floor reveals that along the mid-oceanic ridge there is intense volcanic eruption. It is also studied that the oceanic crust is much younger than continental crust, and the sediments of ocean floor is very thin. It is also saying that huge amount of lava comes out along the mid-Atlantic ridges. It is also informing us that rocks closer to the mid-oceanic ridges are young and normal polarity. The age of rocks increases as the distance increases from the mid-oceanic ridge. This theory is also informing us that the earthquakes are common along the deep sea terrace positions of continents through geological past. So according to these facts, it has obtained from the mapping of the ocean floor and a detailed analysis of magnetic properties of the rocks on the either sides of the mid-oceanic ridge, proposed his hypothesis known as the seafloor spreading. According to Hess, constant eruption at the crest of oceanic ridges cause the ruptures of the oceanic crust, and the new lava wedges into it, pushing the oceanic crust on either side. The ocean floor thus spreads. The fact that the spreading of one ocean does not cause the shrinking of the other, and the younger age of the oceanic crust made him think about the consumption of oceanic crust. Has also mentioned that the ocean floor that gets pushed due to volcanic eruptions at the crest sinks down at the oceanic trenches and gets consumed. To explain the distribution of oceans and continents, in 1967, Mackenzie and Parker, and also Morgan. They independently collected the available ideas and came out with a new concept, that is plate tectonics. What is the plate tectonic theory? We will know about this in our next video. So for that, keep watching SST June.